Oops, not highlighter. Laser pointer. There we go. Okay, so learning outcomes is recap and transition from webinar 1. So if you weren't on the webinar 1, you can go back and listen to a recording of that, but looking at key takeaways and how they connect with today's focus. So how ArcFlash PPE protects, exploring the science behind arc-related protective gear. Understanding the layering of PPE, so maximising protection through the proper PPE combinations. Real-world case studies, so lessons learned from incidents and near misses. And then changing the safety mindset, so building a culture that prioritises proactive protection. So first of all, as a recap and transition for webinar 1, which was a month ago, I believe now. Time flies. So we looked at ATPV, EBT, ELIM concepts to reinforce the purpose of preventing burns and the effectiveness of ArcFlash PPE. So we had the breakdown of the three, so the ATPV, EBT, and ELIM. So these are all open arc ratings that you will receive from an open arc test. Three options you can get there. So 2 ATPV and EBT you'll only get in the US for the ASTM arc tests, and then ELIM you'll get ATPV, EBT, and ELIM, or one of those for the European arc test. So ATPV, arc thermal performance value. So I was looking at the actual thermal performance of the fabric itself. Gives you a 50% probability of the onset of second degree burn. EBT is the energy breakthrough threshold, and that is 50% probability of break open. You always get the lowest of ATPV or EBT. So for example, if it had a 12 cal ATPV, but it only had a 10 cal EBT, you have to put it to market as a 10 cal EBT. You can't market it as a 12 cal ATPV. In some situations, you may get something like a 14 cal EBT, and you may get a 12 cal ATPV. Again, in that respect there, you've got to market it as a 12 cal ATPV. You can't market it as an EBT. And then ELIM is only the European test which gives you ELIM, and that gives you the lowest kind of value arc rating, where they possibly guarantee there's no burns. But as we discussed in the last session, there's not a guarantee that you won't get burnt, but we'll discuss that a bit more detail, or otherwise you can go back to the previous webinar to look into that. So just a reminder why we're here today. So on the left-hand side, you have a light grey topped mannequin, and then on the right-hand side, you have the dark grey one. The right-hand side is polycotton, and the left-hand side is ArcFlash PPE. But the arc itself, excuse me, that's a bit of a bite, there we go. On the right-hand side, obviously, is polycotton, left-hand side is the ArcFlash PPE, but the arc itself is greater than the protection level offered or certified on the ArcFlash PPE. So wait for this ArcFlash to happen. There we go. So there's the ArcFlash. So you can see the ArcFlash PPE. It's got a black front where it's charred, which is its natural state. That's what normally happens with an ArcFlash, completely normal. It's obviously protecting you against the heat, stopping the heat transferring through to the body, or limiting that. On the right-hand side, you've got a garments catching on fire, which is why we go back to saying always don't wear fuel, don't wear something that's going to catch on fire, because the fire will create burns greater than any ArcFlash you can ever imagine. So we hear people talking about, I've got an ArcFlash rating of 100 cal or 140 cal. Well, do you know what? That ArcFlash would never give you the same burns as the clothing that mannequin has given that person if they were wearing that in real life, because the actual length of time exposed to the heat is more damaging than the instantaneous heat that's provided by an ArcFlash. So this is what we get as part of our testing when we're testing fabrics. We get this this line here. So bottom line, the red dots is where there is no burn. The lines at the top, the red dots at the top of the line are where there is a burn, and then we get this mix zone. ELIM is the top dots where it's no burn before they actually get the mix zone where it has a burn and a no burn. So bottom here is no burn, top here is a burn. There's obviously no mixed area, but then this mixed zone is where you've got a mixture of burns and no burns, and then the ELIM looks at the average of the greatest three ArcFlash results that fall outside of the mix zone where they're saying there's no burn as a guarantee. But obviously, fabrics change. So every single time we test a fabric, we'll get a different rating, because the fabric by nature isn't guaranteed. It's not like you're making sheet steel or sheet aluminium, for example. You're making a natural garment with a natural product. So moving on from that, at the bottom corner here, you get the ATPV, EBT 50, and ELIM, which is what we would normally see on a ArcFlash study. But obviously, we then break down what we need to from these for labelling of garments. So the two that we've discussed before, so closed box arc rating only comes with two certification standards: Class 1, which is a 4,000 amp short circuit current, and Class 2, which is a 7,000 amp short circuit current. These are both LV arc flashes at 0.5 seconds. The only thing that changes is the fault current, and the fault current then dictates what the rating of that garment is. If you don't meet Class 2, you don't meet Class 1. You've got to retest for Class 1. If you've got a really good Class 1, there's no 1.5, there's no 1.75. It's pass or fail, Class 1, Class 2. So it's got its limitations, but we test the garments according to these because it's an ejected arc out of a box rather than an open arc. So you do get to understand, particularly from a garment perspective, how that garment performs in a closed box arc against an open arc. So moving on from that, how does Arc Flash PPE protect? So what happens during an Arc Flash? So during the Arc Flash event, surrounding oxygen heats up rapidly due to the immense energy release, causing exposure expansion. This leads to several serious hazard issues. So first of all, extreme temperatures, and that is the number one activity that we're protecting against with Arc Flash. So the heat generated by an Arc Flash can exceed 5,000 degrees C. People talk about it being hot on the face of the sun or surface of the sun, but could look to anyone actually measuring that specifically. But yeah, 5,000 degrees C, it's capable of instantly vaporizing metals and causing severe thermal injury to anyone nearby. So vaporizing metal takes a lot of heat. That kind of probably gives you a bit of an idea of the heat that's generated within the Arc Flash. So molten metal, so conductors or metal cladding can melt and be expelled as molten droplets, posing risk of burns and fires. I'm putting brackets around the metal cladding. I've not seen much in the way of metal cladding turning molten. Generally speaking, it buckles, it bends, it breaks open, pops open. The main thing we get is molten metal from the conductors or any metal components surrounding the buzz bars when that actually takes place. So the conductors, when they vaporize. So molten metal's really, really bad for burns as well. So blinding flash, and this can then be caused by infrared or UV radiation, which builds up that blinding flash. And then obviously coupled with this is high noise levels. But obviously what we're looking at is the extreme temperatures and the molten metal that we're trying to protect from, particularly with the Arc Flash PPE, and obviously blinding flash we can look at with shaded visors, etc. And then high noise levels we can look at with in-ear canal earplugs. Just a recap then on what happens with an Arc Flash. So this here is an Arc Flash which also has a slow motion. It's great that it's been captured on a webcam because it gives us a really graphic detail of what happens. In here, they've also got a panel open, so there's no panels to worry about here. They've got it here with exposed conductors. They've got Arc Flash PPE on. The Arc Flash PPE does protect them. Ignore the barrier. That's another thing for another day. So there's the Arc Flash. So you have that initial ball of heat, you might say. Some might call it a fireball. So the initial amount of explosion around the actual arc itself, and then all the sparks, the firework display, that's all the molten metal ejecting from the arc itself. So your garment is doing two things. It's protecting against the initial amount of heat that's generated in the Arc Flash, and then secondly, protecting against the molten metal that's ejected from that. So how does PPE work? So we're going to look at ignition resistance, the heat insulation, and the garment integrity. So all the garments that we test are all flame retardant by nature. So it means if you apply a flame, they don't burn. There may be a slight flame whilst you're actually trying to ignite the garment or fabric, but when you remove the ignition source, the garment completely extinguishes and doesn't continue burning. So we always use fabrics that are first place going to actually resist the ignition, and then heat insulation and the garment integrity is then what we look at for the actual Arc Flash. So heat insulation is then what we're looking for the Arc Flash, and then garment integrity is then when we test a garment before we place it on the marketplace to make sure that the garment fastenings and findings, etc., are actually going to make sure that they're going to continue working. So if there's an Arc Flash, you can remove the garment completely, very, very easily, and you're not trapped inside a hot garment. So the panel's on the screen right now. So this is what we get from a test report. So in the top left here is where the actual original fabric is. This one is shot 1, so there's 3 panels tested on an open arc test at any one point at each time, and so there is panel A, panel B, panel C for shot 1, and then shot 2, shot 3, shot 4, 5, 6, and 7. So 21 in total. There has to be a minimum of 20, so they're allowing for one of those to fail should it happen or have a false reading. But then you can see all these have got different outcomes, and this is because they do different arc ratings or different arc tests to determine at what point the garment will create a burn or break open or not burn. So moving on from that, we're going to quickly run this video. So this is a video of a mannequin that is has been arc tested by Scanware. It's the SFV 941 winter jacket. I think I might need to press this again. Yeah, I do. So this is the 941 winter jacket. So you'll see this is an actual garment on a mannequin, which you'll see on the screen now. So this is a high-vis garment on a mannequin. You'll see the conductor at the top of the screen. And then there you go. So it's had an arc flash. You'll see all this area is charred here. The sleeves, they're kind of out of the way of the actual arc itself. But you can see all the main yellow area of the body has had an arc flash. So we've already using flame resistant fabrics, which is the resistance to ignition. We then looked at the actual heat transfer of the actual garments itself, the fabrics, which is what I showed you on the previous slide. And then the third stage is actually testing the garment. So this is done for both open arc, which you've just seen now, and closed box arc, where the actual arc is ejected from a box. So moving on from that, this is a bit of an animation to show what happens. So first of all, we have the arc flash protected fabric outside. It has the arc flash on the outside, which is then charred. It's got molten metal droplets on it. And generally speaking, this is what the inside of the fabric looks like, depending on the arc flash. So if the arc flash has not gone through the fabric, the outside will be charred. But generally speaking, the inside will always look pretty intact. There may be a slight discoloration from the heat, but in the main, that is what the garment's doing. So if you imagine the skin on the inside, which is your body, and what we want to do is protect the body from the burn or the heat that's generated on the outside of the garment from the arc flash itself. So we'll look deeper now into this, into labelling. So it's a concern of ours that there are garments in the marketplace that are not certified for what they actually say on the label. So this is a well-known European brand of arc flash PPE. So you'll see here on the left-hand side, all these here on the left-hand side are certified by this body here. So CE0161. If you Google CE0161, you will be able to find out the test house that has certified this product that I've got on the screen here now. And these are the certifications that it's tested for. So the top one is a welding specification. The next one down is a flame retardant specification. A1 is surface ignition. A2 is edge ignition. B1 is convective. C1 is radiant. And then D2, E2 are metals. And then F1 is contact. EN1149 is anti-static. And then this here, which I want to particularly highlight, is the EN61482-2 2018. So this is an arc flash method certification. And then under here is the actual data of what the garment has been tested to, as well as the fabric. So in this situation here, the actual garment is certified for class 2 closed box arc test. So it's had a closed box arc test as a garment and a fabric. Okay. But then over on the side here, you've got an arc rating IEC 61482-1-1, which is the European equivalent of the ASTM F1959 arc test. So in this situation here, it's showing us an ATPV of 39 cal. But this here is an arc rating of the fabric only. So the fabric has been tested for 39 cal. However, it's not being tested as a garment in a 39 cal arc. It's only tested as a garment in a class 2 arc. If you're on the webinar last week, class 2 arcs can generally be attributed as an equivalent basis between kind of 15 and 25 cal. So when we get to arc ratings of between 15 and 25 cal, we can generally test that for a class 2 arc and achieve a class 2 arc results. However, 39 cal is a lot greater arc flash rating than a class 2 arc. So would we be safe wearing this 39 cal garment when it's only being tested as a class 2 arc? That's a question. And normally speaking, we would say I wouldn't do that we're selling a class 2 arc garment because ATPV 39 cal, the actual zippers, etc., may not actually protect you in the event of a 39 cal arc flash. So in this one here is a North American label for garments. So first thing is here, the garment is compliant with arc flash and flame resistant standards, and it's quoting NFPA 70E, which isn't a standard for clothing. It references ASTM F1506, which is a standard, and NFPA 2112, which is a standard. ASTM F1506 doesn't need to be certified. It can be self-certified rather than through a body. NFPA 2112 is certified. You can't just have a compliance. So in this situation here, this label is telling you that it's compliant, but it's not actually telling you it's certified. So there's no guarantee that this garment is going to protect you against any of these standards that is stated here. And then secondly, on here, you've got this do not remove. The durability of the frame resistance of this Mount Vernon fabric is guaranteed for the life of the garment, provided that all recommended laundry instructions are followed in block letters. So this here is telling you that if you launder it not quite according to standard, then you're not going to guarantee the flame retardancy of the fabric, which would also mean you're not going to guarantee the arc protection of the fabric. So here it's saying it's PPE category 2. It's also saying on the third label, it's saying that it's underneath this cotton. So down here it's telling you it's 20 cal ATPV. However, this label here and this label here would then make you question if the 20 cal ATPV is actually correct, because ultimately speaking, this here is meaning that if it didn't protect you in the event of a 20 cal ATPV arc flash, so you may have equipment rated 20 cal, you may wear this garment because it's 20 cal, but then if the arc did burn you, then this is their warranty or disclaimer to say that the garment may have been washed wrong and therefore not protect you. So it's not an inherent fabric, it's 100% cotton, it relies on a treatment is washed in, and treatment also washes out. So as it says at the bottom here, do not use starch, fabric softener, or other laundry additives. Well, I'd like to go to a laundry, look at laundry cleaning detergents and find one that's not got any additives in, or also what is this additive here. So a lot of confusion in the label, no clear certification on the label itself, and obviously there's a very much grey area as to whether this garment will protect you when you need it most. This is one of our own labels. I'm going to preach this from the top of the houses because we do a lot of work behind this. So here we go back to our EN 61482-2 2020, which is the Art Flash PPE certification standard, and we're certifying it to APC1, which is Arc Protection Class 1, so the Class 1 closed box arc. We've got an ELIM 10 cal because we're doing our European arc test and it gets 10 cal ELIM. We're also doing our ASTM F1506, which also gives us the ATPV of 12 cal. So we're doing 3 arc tests for this garment, and we're actually certifying those. So we're certifying it in a closed box arc as a garment, and we're certifying it as an open arc in a garment. Next, obviously, you've got the other standards that are on here now. You can see all the symbols under here, and these are all certified by the test house CE 2895. You can check that out. It's Shirley Technologies. They're in Manchester and in Dublin, and they do the certification on this garment, so you can get the information from them if you need to. And then here is our fabric composition. So very, very clear what the fabric composition is, and you can see on here you've got 4% monocrylic, you've got the 5% aramid, and the actual polyamide FR. So you've got basically 3 FR components, and then obviously a 30% cotton, 1% antistatic. So these are inherent fibers within a garment. The garment is inherent, and you'll see on here there's no mention of not using softeners or bleaches or additives in the laundry process. You can wash these how you like, and the garment will still give you the same protection regardless of how many times you've washed it, how many times you've worn it. So if something that's been sat in the back of a truck for the last 10 years and you decide to pull it out and you're not too sure how many washes it's done, it will still give you the same protection that the label says. In this case, ATPV 12 cal, or if you want to do ELIM 10 cal or closed box arc class 1. So moving on from that, we're going to have a quick catch up on the Q&As now. So Ben, if you want to read out some of the questions that have come in, and we'll try and answer those. But it looks like a lot of stuff here. 43 chats in here, so
No, don't worry.
That's a lot. Fire away, Ben.
No, I'll just chit chat in the chat. So the first question is from Sales. Apologies, I've got that wrong. So why Art Flash PPE over maintenance strategies and Art Flash assessment with mitigation measures?
Very good point. So on that, I will definitely recommend maintenance measures. This is really important. So we're talking here now about the last line of defense. So in the hierarchy of controls, it is the bottom line of hierarchy of controls. However, would you drive a car without a seatbelt on? I personally have seen a lot of incidents where seatbelts haven't been worn and the devastating impacts that they cause. And cars nowadays have got all kinds of sensors that will brake for you and already pick out warnings through ABS systems on the braking. But however, the seatbelt is the last thing that actually keeps you in your seat in the car. The same thing is PPE is going to stop you getting burnt. So going back to the first slide, or one of the first slides I showed you, the Artful PPE isn't being worn on the polycotton garment. That is what most people wear to work as a general work clothing to work. And if that's not arc flash or FR rated, then if there is something goes wrong and there is an arc flash, then you're going to end up with a situation by arc flash PPE will be the thing that protects you. So ultimately speaking, yes, we recommend maintenance that stops arc flashes. Yes, we recommend working practices which eliminate arc flashes, and yes, we recommend engineering out the arc flash where possible. But obviously, everyone has got a budget. Everyone needs to make money, and at the end of the day, it's balancing the books on what is the most economically viable option for the business. And as a backstop, we obviously sell PPE. If you don't want to wear PPE, don't wear PPE. We're just trying to save lives. So I hope that helps, sellers.
Yeah, thank you for that, Sally. So moving on to the next one from Hannah. So are all tests slash standards different depending on country slash region?
So the European tests are all with an EN number. So the EN tests, so EN ARC tests are for European nations, and nations that don't fall under the EU regulations, they can adopt those. So countries outside of Europe and outside of the US can adopt standards depending on how they fit. But however, when it comes to Arc Flash, there's only two standards available. That's the ASTM F1506, which is also aligned with CSA Z462, and then also in there is the EN 61482-1-1 open arc or -1-2 closed box. But the USA doesn't have a closed box test. If they want it in the USA, they use the European closed box test to define that. But generally speaking, Europeans have their own norms and ASTM have their own standards as well. Hope that helps, Hannah.
Perfect, thank you. So moving on to Igor, what is the lifetime of scanware PPE?
So good question. So there's no lifetime. So if you've got a high-vis garment, there would be a lifetime depending on the reflective tape and the fluorescent fabric. So the fluorescent fabric is generally the yellow or the orange fabric of the garment. As to how bright that is it still bright as when you first bought it, or is it dull to a point where it's no longer applicable? The reflective tape, is this dull or is it usable still? But the actual art flash properties of the garment and the flame properties of the garment are there for the life of the garment. So it doesn't matter how old the garment is, how many times it's been washed, as long as the garment is intact, so no holes or tears or rips and things like that, the garment will always protect you. So if you bought me a garment that's 10 years old, it's been worn every single week and washed every single week, but it's still in one piece, I will guarantee you it will protect you at the same arc rating as the label in the garment says. And actually, in fact, possibly slightly more. We've done some arc tests, a longer period of washes, and most of the time we get a higher arc rating. So over time, fabric compacts and provides better arc rating. Hope that helps, Igor.
Good stuff. One more answer and we'll move on. So this is from Salas again. So what about undergarments and cleanliness of the overalls?
So undergarments we're going to touch on in a short period of time. Cleanliness, we always recommend to wash the garments. So I come across a lot of people when I'm out and about in the field, people saying they're not washing the garments very much, or maybe just doing it once a week because they don't want to wash out the flame retardant properties because they may have heard or have known of treated fabrics where every wash counts. But in this situation, we would always recommend that you wash your garments on a regular basis. It's better to have a clean, hygienic garment than a dirty one. We often get questions about grease stains and things like that. But actual fact, once a garment's been through the wash, the things like stains from petroleum-based products may stay on the garment, but the actual ingredient that causes a petroleum product to flame has long gone out of the garment, so it's just a stain left behind. So in those situations, if a garment is still stained from one of those kind of products, the garment will still be intact as long as the actual integrity hasn't been damaged. So if it was like I don't know, acid or something like that, then obviously yeah, the integrity would be damaged and you'd notice it. But other than that, good to wear, and hope that helps.
Have we got time for one more, or should we save it for the next part?
Yeah, go for it. Yep, there's one more. Yep, yep.
Yeah, good. So this is from Jeff. So hi, Jeff. We work in paper mills in the summer, and it is very hot and humid. What do you recommend would be the coolest ARC-rated 8 cal clothing?
Okay, that's good. So when you yeah in the hot and humid environments, it's probably the most challenging environments to protect against in those situations. There's a lot of lighter weight garments on the marketplace these days. We do a shirt ourselves that's 8.2 cal, 80 PV, very lightweight, 190 grams. It feels like you're wearing a pair of pajamas, to be really honest. But yeah, so you can go down to that kind of weight and still protect against 8 cal. And we would always generally recommend when it's hot and humid to wear something like a shirt rather than a t-shirt or a polo shirt. So a t-shirt or a polo shirt are both knits. Knits were originally designed to keep people warm. So you think back to woolen jumpers, etc. So in a knit, there's lots of air pockets in the fabric itself. So those air pockets can heat up and kind of retain the heat. With a woven, there's not so much air pockets in there. It's a more tighter weave. The fibres and yarns are tighter together. So as a result, the shirt will generally create like an airflow gap between the body and the shirt itself, and actually allow a lot more airflow through the body itself. So yeah, hot and humid, we definitely recommend shirts. And if you're in a cooler climate, we'd definitely recommend polo shirt or t-shirt. I trust that helps, Jeff. And obviously for trousers, we try and go as light as possible, but at the same time making sure that they're as durable. We can do very lightweight trousers. We've got a very lightweight coverall. Again, same fabric, 190 gram. But on trousers, generally get me more harder wearing. But if someone needed a 190 gram trouser, then be our guest. Let us know, and we'll make one for you. Trust the help, Jeff.
Thank you, Anthony. Keep going.
Yeah, good. So we move on now to our next slide. Not there, so it's not on my screen. Here we go. So I thought I'd stop then. So understanding the layering in PPE. So we talked about the general arc flash, what happens, how it protects against heat from the arc flash and protects the wearer. But we do a lot of work as a business on layering. So you have this Strata Arc Flash layering matrix. So if you have a Scanware catalog, you'll have it at the back of the catalog. And I believe it's also available online to download. So in here on the left hand side, so down the side here is all the garments we would expect to be worn as a base layer. So you have a t-shirt, shirt, polo shirt. I've just got a snapshot here, so there's other garments that form part of the base layers. And at the top here is the outer layer garments. So we've got a fleece here. We've got two soft shell jackets. So SFX 405 is a navy or grey version of the soft shell. SFV 405 is a yellow and navy soft shell. And the SFX 408 is one of our jackets, which we have matching trousers and coveralls to go with that. So what we're saying here, so in this first piece here, we've got a t-shirt. It's 11 cal. When it's worn with an 11 cal fleece, we've got a 39 cal arc rating. So 11 cal 80 PV t-shirt on the inside. On the outside is 11 cal EBT. So this is energy to break through fleece. And we have a 39 cal 80 PV. On this side here, we move along. We've also got 39 cal. And this soft shell jacket is 28 cal outer as an EBT. So both these outer layers are EBT. But here we've got 39 and 39 for both of these. When we jump across the page a bit to here, we've got 36 cal with a 12 cal 80 PV outer. So just a 3 cal drop. And yet here we've got 8 cal, 11 cal EBT. We've got a 12 cal 80 PV. So you can see when you're layering garments up, the difference in the actual ratings once you take an 11 cal 80 PV base layer and you add on these different outer layers, you're then getting these different arc rating outcomes. We'll move down here. So this t-shirt, unfortunately the ATPV level's not dropped through here, but this t-shirt here that we're on highlighting at the moment is an EBT 9.3 cal. So it's a lower cal rating than this because we've got to mark it as an EBT, not an ATPV, but it's EBT 9.3 cal. So with a fleece, it drops lower than the 11 cal t-shirt and it's 35 cal. With a soft shell, so same soft shell here, we've got 39 cal with 11 cal ATPV undergarment. But when we move to a 9.3 cal EBT garment and we have the 28 cal EBT soft shell, we jump up to 47 cal. So with a t-shirt and a soft shell, we can be over 47 cal. So most switching suits are at 40 cal, and we're over that by another 7 cal. Okay, and then here, ATV at 34 cal, it drops down by 2 cal when you wear it with the jacket. Okay, and then next one on down from that is the shirt. So the shirt is 8.2 cal, what I mentioned before to Jeff on the questions. So this is 8.2 cal ATPV. With a fleece, it's 32 cal. With a soft shell, it then goes to 45 cal. Okay, so it's less cal rating than this t-shirt, so it's 8.5, 8.2 cal, whereas this is 11. But when it's coupled with a soft shell, it's 45 cal rather than 39. And then when we do it with the jacket on the outside here, we get 33 cal. So there's a big change in that. And then last but not least is the polo shirt at the bottom here. So we've got 35 cal with the fleece. This is a 14 cal EBT polo shirt. And then we get 48 cal with a soft shell. So even though this is 14 cal EBT and this one here is 9.3, but only 1 cal more with the soft shell. And then over here, you've got 36. So we're in the 30s here. And then in here, we're mostly in the 40s, but obviously with the exception of the 39 cal here. This shows you that without the alpha matrix, we don't understand what the actual layering will work out at in terms of protection. But we also see, generally speaking, when we have two EBT levels together, depending on the outside level of the EBT rating, we can often get a higher arc rating with two EBTs because the outside layer acts as like a cushion for the impact, breaks open, and then reduces the amount of heat that then comes through to the inside of the garment. Okay, so we're going to do a poll here. So the question will be, if I have an 8 cal t-shirt and an 8 cal jacket, do I achieve 16 cal, less than 16 cal, or more than 16 cal? So the poll is on the screen now. It should be showing for you. So 8 cal t-shirt and an 8 cal jacket, do I achieve less than 16, 16 exactly, or more than 16? So this is a bit of a teaser. But I'd be interested to see where people put their results.
I'll give it another 10 seconds, Anthony.
Yep, very good, Ben. Thank you for that.
5, 4, 3, 2, 1. And these are the results.
Okay, so do you know what? None of you are right, and none of you are wrong. Okay, so there's no ability to say I've got an 8 cal t-shirt and an 8 cal jacket, I will achieve 16 cal. There's no actual guarantee that that will be the same. However, what you've just seen on the previous page, they are all greater than the sum of their parts. So we were talking about 11 cal fleeces with 11 cal t-shirt getting 39 cal. We were talking about a 9.3 cal with a 28 cal getting 47 cal. So in the main, we generally get a higher arc rating than what we start off with if we just add the numbers together. But that's not always the case. And we're going to move on to this next slide here now. So the same applies for the closed box arc test. Class 1 garment plus a class 1 garment doesn't always equal a class 2 protection. You've got to test those. And again, same again, 8 cal garment and 8 cal garment doesn't always equal 16. So we talked about before where it does work. In this situation here now is where it doesn't work. So we have a 10 cal EBT trouser. It's made of the same fabric as the coverall at the top here, which is also 10 cal, and we end up with a 17 cal ATPV. So this should, if we used our plus methodology, we should be getting over 20 with this combination here. But as you can see here, we're only getting 17. So it doesn't always work. It all depends on the actual fabric itself and how well the outer fabric protects in a higher arc rating. So the soft shell is 28 cal. When it's got a higher arc rating against it, it withstands a lot more before it actually bursts open. And then when it bursts open, it releases a lot of energy. So what the undergarments underneath that don't have as much energy to absorb. So this here is an arc flash of a jacket fabric or coverall fabric with a polo, or a t-shirt fabric underneath. So the outer of this is 12 cal. The inner of this fabric, which you can just see is a Harvey's yellow fabric. You can see the yellow poke out the top here. Okay, but the outside face is a 12 cal ATP fabric, and the inside is a 9.3 EBT. And we'll start watching this video. Um, so this first arc here, you'll see just up here now, where it's just moved on. Sorry, there's a bit of an error with that video. Sorry about that. So here, the outside is completely obliterated. So you've got the yellow garment you can see underneath here. All the outside here is completely gone. It's broken open. This is quite dirty, so it's got quite a lot of char, lots of dots on it, which are the molten metal droplets that have gone through after the outside. So the outside's broken open quite early here, which is why you can see a lot more darker areas on here. Here again, you've also got a lot of darker areas here, but obviously a lot of molten metal splash on here where it's broken open. And then there should be another one, I believe, on this video, which will come through now. But you can see the conductor quite clearly, and they have a fuse wire. So the next one's the conductor and fuse wire. Okay, so here we've got a lot of char across the whole of the garment, and this last one here, you can see the garment outer has gone, and the inside is more char. There's not so much molten metal on this one here. So all the garments on this art flash, so this is all the same fabric. So this one here, the outer has broken open with a lot of force, and obviously the inside here is probably the least burnt. So the other side of this yellow fabric will be completely intact when you've got this much char on the outside. So you think of the force of the art flash. This art flash particularly here is around about 32 cal. And you can see here you've only got a slight bit of char, a few molten metal drops, but the outside fabric is completely gone. So this is the advantage of having two layers. You generally always increase the art protection. So what not to wear under the PPE? So going back to the question we had before, so we're avoiding nylon, polyester, and acrylic. So basically anything that will melt. So number one thing on there is your sports tops, whether that be your favorite baseball, basketball, football, rugby club. And then we're also making sure that we're not wearing gym garments or sportswear garments that may be highly content of acrylics and polyesters and nylons. We're making sure we're avoiding all those, particularly when we don't know the art creating of the gear that we're working with. So if we knew, for example, that we've got a 30 cal arc flash rating and we're wearing a 40 cal suit, yes, we never recommend wearing these garments underneath it, but you may get away with it in that case. If, for example, you're not aware of what the arc flash rating is and you're wearing maybe a category 2 arc flash PPE, then there's a really high chance the arc flash PPE will break open and the inside garments will be exposed directly to the heat and either ignite, like you have in the image next to us here, or it would melt. Last thing we want to do is have acrylic or polyester or nylon melting into the skin. It's horrific to get off. You'd have to literally grind the skin off and have a complete skin graft to replace that. So no one wants that. So don't wear it. If you're going to wear non-FR undergarments, make sure the cotton, wool, silk, all those garments have got a high limited oxygen index and won't ever melt or burn. So they're quite safe with those. So unknown arc energy exposure is obviously risks of guessing without a study. And outside determines whether a base layer is necessary. So these are two real world case studies. So 10th of October 2024, a day a life was saved. So the person on the screen you see here now on the side here, you see the polo shirt of the actual wearer. This one here is had a panel cut out by emergency service to help take the garment off the actual wearer itself. But as you can see, the wearer is extremely badly burnt. The face is black from the burns and was in a very, very poor way. So we talk about last line defense. So here we're called into action on the Thursday the 10th by an engineer based in South Africa. So as you can see there, the engineer was exposed to an arc flash from 11 kV circuit. Fault level of actually it's actually meant to say 2 Ka for 0.21 seconds. But this is the arc flash that happened. They thought the equipment was dead. They'd proved dead. But unfortunately, there was a second circuit within the system itself. And because they were using contact detectors, not non-contact, it wasn't flagging up that it was still live. When they were applying a breaker, the breaker caught a loose wire, went across all three phases. So this person here was at the back with the sleeves rolled up and no face protection, no hand protection. So you can see on the sleeves of the garment here, you've got these quite clear yellow areas here, and the black on the very end, and on the middle here, and the shoulder, which is where the sleeve was rolled up. So the worker received really bad burns to its arm, neck, and face. But fortunately, has made it, and he's now back at work. But it just shows you when you think you're completely safe, and something can go wrong. And that's why we specify or recommend people wear PPE for the unexpected accidents that happen. So obviously, second and third degree burns to the forearms and face, but doing well and back at work, and they were back at work in December full time. So great victory in that aspect. So 839 overall. This is another one happened. So again, last day before retirement, 62-year-old SAP approved the work without checking for the absence of voltage. It was 11 kV oil-filled switchgear. The worker who was actually working on this was only one with artificial PPE on. The apprentices didn't have any artificial PPE on their polycotton garments, and the worker was showing the apprentices how to drain oil out of the oil-filled switchgear, and in doing so, bridged the current between two 11 kV conductors and caused the arc flash. So you can see the garment is not kitted out for arc flash at 11 kV. It's a 10 cal garment, but you can see the whole outside of the sleeve has just disappeared. It was held on by the two reflective bands because again we talk about two levels, two layers of arc PPE. So the two layers here made it stay together, and obviously the rest is just burnt away with the arc flash, and obviously the skin did take a lot of a hammer. But again, the worker was back at work with a fairly short period of time. But the polyester beanie vaporized that they're wearing, and obviously they had a lot of work to do to rescue their hand. But this here is the pen pocket we have on the sleeve of the coveralls, and you can see again it's a second layer. The outside layer is completely gone, but the inside layer is pretty much unmarked. So again, when you wear layers, you normally always increase the protection as a rule. On occasions you don't, so it's worth checking. So changing the safety mindset is one of the things we want to carry on doing. So better than nothing is it equal to good enough. So Artflash garments offer more protection than the label says as a general rule. So if in doubt, wear Artflash PPE and do not wear non-FR clothing. As we mentioned before, the issues of wearing non-FR clothing, best will in the world, safest systems. If it requires some kind of form of interaction, then at the end of the day, you do need Artflash PPE to protect you from that situation. So this jacket here is a waterproof jacket. It's a 24 cal rated jacket. But as you can see, it's been exposed to a 26 cal open arc. So a higher arc rating than the actual garment is made for, but the garment has stayed intact. So although some heat would have gone through, the garment stayed intact, and the wearer, if they were wearing this, would have walked away maybe just a little bit sore. But other than that, completely intact. So sometimes you may not fully know the Artflash rating. Err on the side of caution, and also make sure you've got your Artflash PPE. So from awareness to smart habits, so we've talked about the awareness of actual Artflash PPE. Then if you've done Artflash studies, is then making sure that Artflash study is implemented properly. So A, understanding what the actual levels are of the Artflash rating, understanding the risks of that, and then making sure that your labels clearly identify the hazards that are present with that piece of equipment. And then next to that is having the visual reminder of what you need to be wearing to protect yourself in the event of an arc flash. So in this situation here, we've got a 16.2 cal arc flash, which is over here. Okay, a working distance 45.7 centimeters being calculated here. And then with that, we've got a lightweight t-shirt and pants, plus a coverall, helmet visor combination, and the gloves on the outside here. This combination will then protect you from a 16 cal arc flash. So rather than having a 16 cal arc flash and people wondering, well, what actual PPE do I need to wear for that? This here is then a reminder of what you would need to wear, and this then gets customized depending on what the company profile of PPE looks like to make sure, as a visual reminder and as a secondary warning, there is a hazard. This is how we're protecting the hazard as a last resort from our engineering controls. So, any more questions with that? Ben, has any more come through
Yes,
on the
yeah, a
chat?
few more come through. Yep. So this one's from N Ross. Sorry, there's no first name with this one. This one goes back to the layering. So if
Yep.
your outer layer is breaking open at 11 cal, how can the twin layer rating be 39?
So the outer layer is breaking open. So when you have a break open on a fabric, so I mentioned if you were on the last webinar, I mentioned about the fact that sometimes break open is better than the ATPV. And the reason for that is when it breaks open, it releases a lot of energy. So a lot of heat is obviously built up behind the first layer. When the first layer then breaks open, a lot of that heat and the molten metal is already dispersed. So the inside layer is then just acting purely as an insulator, and a lot of the energy has been taken out of the initial first garment. It's when you do artificial test all the time, you see that pattern repeatedly, which is why when we get the soft shell as well, we also get a higher rating with that because it takes a lot more force to A, break open the fabric in the first place, and then the inner garment then acts as your insulator. And then if you have an insulator on the inside, we sometimes then get a higher rating, but obviously not always. But generally speaking, an outer layer and an EBT, we do generally get a higher rating because the energy is broken. When the fabric's broken open, it's released energy and heat, and obviously then the inside is just protecting against the heat. Hope that helps, Nigel.
Perfect, thank you, Anthony. So for the next one's from Siobhan. So which of those values would you go with when figuring out your art flash requirements, elim or APTV, ATPV, sorry.
Yeah, so ATPV is what we'd always advocate. So elim's a hot topic in Europe. Um, if you were on the last webinar, or if you weren't, you can get the recording for that last webinar. I think it's online now, or we'll send you a copy of the last webinar if you weren't on it. But in there, we talked about the discussion of elim, ATPV, EBT, etc. Elim is saying that this is the point at which you won't get burnt. However, when you do, if you go back to, I didn't actually touch on this before, but the elim results generally when you have a dual layer system are a lot lower than the actual ATPV or EBT because it's so much more variable. However, it would then mean that people are wearing garments that are actually probably really restrictive and heavy if you were to use elim as the base level. And then what we talked about as well is that generally speaking, the garment will offer you more protection than the arc rate of the combined arc rating of the actual garment itself, plus the combined rating. So when we test a garment, we actually test the garment at a higher arc rating the fabric is meant for to make sure its integrity. And then when we look at the dual layer systems, again, we obviously have an air gap in there and it creates more higher arc rating. When we test a dual layer system at a higher arc rating, we get really good results. So it's actually protecting the wearer more because when you then wear a garment, you've got air pockets in between the two layers. You have air pockets in between the actual last layer and the body, generally speaking. And then you have things like pockets, fastenings, zips, plackets, etc., which all add extra layers and protection to the garment itself. So the lowest case scenario would be if you had two t-shirts on, which are quite skin tight, maybe that you would have to rely on the ATPV rating of the fabric itself. But generally speaking, we always say if you're layering up, you use the ATPV for a definite, and also you would generally get a higher arc rating than the layering combination itself.
Good stuff.
Thanks, man.
Thank you. So moving on, Ricardo. So where do we get the underwear from? If you can provide some recommendations, Anthony.
Yeah, so underwear can be bought obviously lots of different places. We do FR underwear. Otherwise, if you didn't want to spend the money on FR underwear, most underwear retailers would do a cotton underwear. So I could go to, I don't know, Asda supermarket or supermarkets in the US or wherever you're based from, and most supermarkets or clothing shops would do cotton underwear. And obviously, if you don't want cotton underwear, then we can supply you with FR underwear and also our graded underwear as well, if that helps.
I'm just touching on the Hannah in the chat as well. That's the same for women's underwear as well, isn't it?
Yeah, that's right. Yep. So we do a range of women's underwear. So either cotton underwear, if you can get cotton underwear for women, which I believe you can do, or if you wanted to go kind of above and beyond cotton underwear, we do a range of our underwear for ladies, and that is using, generally speaking, a wool based fibre, but it's also arc rated as well, and that can be bras and briefs. And we're also working on a new bra at the moment. We're working with some female technicians to get a new bra which gives a bit more support and it's got padding and things like that in it. So
Just touching on what Ross said in the chat, we don't want wire bras. That's correct, isn't it, Anthony?
yeah, that's correct. Yeah, so we always say to not recommend wire bra, more like your sports bra is the way forward on that. Obviously, yes, a wire bra will probably be nice for some ladies to wear, but in this situation, there is a chance, obviously, that the wire would heat up. And we don't really want any burns. However, if you're wearing um, a dual layer combination, we're talking about the actual amount of heat the body receives. The body wouldn't receive enough heat for the wire to heat up, if that makes sense, because otherwise, if there's enough heat for the wire to heat up, then the body's going to be burnt. So in this situation, we're talking about the body not burning, and the body not receiving enough heat. So in some situations, a wired bar would be fine, but most wired bars have obviously made of polyester and nylon and acrylic, so the actual fabric itself is a non-starter.
Thank you. So moving on, this is from Darren. So do you analyze this clothing that is involved in these events to constantly improve your PPE? Who does this? Is this done in-house?
So put my hand up on that one. So yeah, so we do it ourselves. So both those images there. One of the images, one of the garments, the overall, I left with the company that owns that overall. They wanted to keep that themselves for their own internal use and discussions. They changed their whole Artford PPE mindset after they'd done that, because at one point they stopped using Artford PPE, and it was kind of a reminder that it's good to have a backup in terms of Artford PPE. But the polo shirt and trousers that you see the person wearing on the first slide, that is here. And then also all our garments that we arc test, we bring back here. Now, when they come back here, they're being transported back from Spain or from the US. So, unfortunately, they do get a bit more damage with the with freight. Parcels don't, unfortunately, they're not immune to getting thrown around. And then once a garment has been in an art flash, it chars, and that char makes it weak. So we've got garments here, and over time, more parts fall off the garment, because that's what it's designed to do. It's designed to char, it's designed to get weak, and that protects against the art flash itself, and the heat can transfer into the body. But yeah, we're constantly looking at our art flash ratings. So I've just been doing some dual layer testing for a new product we're bringing out to the marketplace, and so I've had 3 arc tests arrive at my desk this morning, both an open arc, closed box arc, and USA arc test for the fabrics, and then we analyse how that garment performs. Is it performing how we want it to, or do we need to go back to the drawing board and get a better combination?
Perfect. Thank you, Anthony.
Thank
So
you.
moving on, this is Phil. So a bit like Jeff's question earlier, we work in the wind industry all year round in weathers and need to wrap up warm in the winter but stay cool in the summer whilst keeping layering in mind. It would be good to get to know recommended clothing to cope with all conditions. In brackets, climbing turbines in the summer can get extremely hot.
Yep. No, that's fine. It's something more we can probably discuss on a call. So you're more than welcome to drop us the line, and we can arrange a call. We should discuss that and how we actually what we'd recommend. Um, we do a lot with the wind industry, understand the extremes that they can get in the wind industry, and understand as well that it might be in the middle of winter, but the turbine, if it's been running, can be very hot. And then depending on what turbine you're working on, I know that some of the offshore ones can be running up to like 40 degrees C with a really high humidity rating. So we are fully aware of that, and we do a lot of work to make sure that the technicians stay comfortable at the same time as being protected. So more than welcome to take that offline and address the situation one to one if that helps.
Perfect. Thank you. So
Is
this
there any
one,
more questions, Ben? Is there not? I'm just conscious of
3
time.
more
A couple more
questions.
slides. Okay, we'll try and blast through those 3, and then we'll finish off with 2 more slides,
You
I
sure?
believe. Yep, go for
Yeah.
it. Yep.
So, what is the difference between limited approach boundary and the art flash boundary?
So the art boundary is basically the actual distance the art flash is calculated to go to. But at the art boundary, that's the 1.2 cal, which we talked about on the first webinar last week. So that is where the art flash is likely to be its least strength in terms of heat and velocity. So this is generally where people would then say within the art flash boundary, you need to be wearing art flash PPE, and the limited approach boundary is the actual point where you need to have where you need to be supervised before you start work. I hope that helps on that one.
Thank you. Do you want to save these last 2 or do you want to do one now, Anthony?
Yeah, we'll close out on this one. I'm just conscious of everyone's time. If people have got other meetings to run to, I'll move on. If that's okay, Ben.
Yeah.
So CanScan will help you. So first of all, do you need help building a layering matrix? Do you need a template to work to? And do you need help with switchgear labeling? So all these things, we can help you in formulating a PPE system that works for your business. Okay. So last thing here is the Electrical Safety Operational Reliability Conference in 2025. So this will be taking place on the 15th and 16th of October 2025, and this will be at the Westfield Marriott Hotel, Chantilly, Virginia. If you would like to attend this, you're more than welcome. The link is on the scanware.com website, or it will be also in the follow-up email that follows this webinar. The more the merrier. We look forward to seeing you. The seats are filling up fast, but we'd like you to join us if you can do. And that can be from anywhere across the globe. And then also to announce upcoming UK conference, which is in 2026. This will be in February. We're just determining the date at the moment, and the location will most likely be in London, UK. But again, anyone globally is welcome to attend this conference, and we look forward to seeing you there. But I appreciate everyone joining today. Thank you for your time. I hope we've got some benefit from joining the call today. There will be a recording going out of this session with a slide pack. And obviously, if you want any more questions or you'd like a conversation offline, then by all means, let us know, drop us a line, and we'll be in touch. But I'll say any questions you need to have, or if you've got a query or concern in your own workplace, then by all means, let us know, and we'll do what we can to help solve the problems and questions for you. So trust that's okay, and thank you everyone for joining, and really appreciate it, and we'll look forward to seeing you next time. Thank you.
Yeah, thank you everyone. Another webinar next month too, so look out for that in the follow-up.
Yep, we'll keep you posted. Thank you.
Right, I'm going to close this down in a couple of seconds now.
Yep, thanks, man. Thank you for that.
Yep, thank you everyone.
Thank you all. Have a good day, evening, morning,